Okay, so one thing I did not try last time was convolution. So I'm gonna try it. We'll go through roughly the same process, try to cut down on the copy paste, and see if we can get above that 95%. There. Okay. So that hit download the thing and then break itself. Self.net equals nn.sequential. And then what do I put in here? Okay, let's start with a conv layer. How many input channels? Kernel size, let's just do a 3. I'm just gonna do a 3 by 3 and then stride of 1 and padding of 1. So this is probably just standard stuff. I'm gonna do 2 layers of convolution and then transition into standard linear. Well, so I'm indecisive. So what I'm gonna do is I'm gonna kind of decrease but also increase the size and then flatten everything. What am I even doing? So the plan is make the thing big, then make the thing small, then make the thing big again, then make it smaller. And then hopefully it won't take too long. Again, the lack of a GPU is going to be absolutely painful. Running into a slight issue where it's a bit difficult to do this idea, but I have some strange idea to get around it. Okay, so my idea was to do global max pooling, but I don't think PyTorch has global max pooling, which is a little bit problematic, but I can just do it manually because it's really easy to do. Okay, so that's the parameters. And then for activation, what I need to do is first get the last image, like the feature image, by passing it through the convolution. From there, I need to pool everything globally by doing max. So dim equals, and then there should be 2 dimensions. And then finally, just pass the result through the fully connected layers. Instantiate the model and pray to God it works. Okay, it didn't go poorly, which is a good thing. I should probably add comments, but I think it's fine. Okay, let's just try passing it through the model and see what happens. It broke. Why don't you work? Okay, so maybe I just do 1 dimension at a time. Okay, it seems to work. Good, so yeah. So passing it forward works. opt.0 grad loss.backward opt.step. So how will this do? 1 around 2. Oh, that looks nice. That could be better. Okay, I'm gonna. Oh, that's good. That's good. Okay, I'm gonna let this train, and then I'll do the visualization thing. Rows times. So I want as many incorrect images as possible. So last time I just clicked enter until I found a bad image. This time what I'm going to do is I'm going to keep rolling in the code until I get a bad image. So hopefully this will be much better. Is there a do while loop in Python? Why doesn't Python have a do while loop? plt.title. Okay, and I'm going to use the title to display what the prediction was. Okay, so here are, oh my god. Okay, so, oh dear. That is not a that's not a 5. That really isn't a 5. That's not a 1. What is going on? Why is this worse than last time? Okay, so what I need to do is I need to train it again. Well, I guess after each what I can do is after each epoch just print the accuracy. Okay, so I'm gonna train it again. I've added a little accuracy thingy to make it a bit nicer to look at. I don't know if this is gonna work, honestly. Ran into a little bit of issues with this accuracy thing. But hilariously, every time I make a mistake, thing trains for 1 epoch because accuracy is evaluated after the training. So that does mean this thing is getting some extra epochs. Well, looks like the accuracy is mostly working, which means training time. This will take a while. Well, I mean, on the bright side, I reached 95. It's a little bit above 95, so technically speaking, I've already won. But we don't want 95, we want 100. So I've decided to set 32 epochs at snail speed. So, well, got a lot of waiting to do. Okay, training complete. That is around, well, it's closer to 96 now, which is good, So, let's see. We'll plot the wrong ones again. First of all, that's a gamma. That's not a 4. So we'll excuse that one. I'm not sure how this is a 0. That's a 2. This is 100% a 6. So there are some still major inconsistencies. I can try the encoder decoder thing, but I highly doubt it'll make a difference in this case. So as of now, I still stuck at machine learning, but next time we can try something new and see what happens. I'm already recording on a laptop microphone. Do I need a garbage truck outside?